All right, so today we covered a few different things, but you wanted me to do some record a chunk of it. So I'll just hit the high points and then dive into histograms and Pareto charts. So we talked about variation, how it's the enemy of quality. You can have variation within piece, from piece to piece, from within a single piece and from one piece to the next. And you can have them in batches. So from one time to the next time, or batch to batch, you can have them happening at the same time, but maybe you're making them in one place versus another place. That happens a lot in food service and so on. And so we try to, you know, find the cause of these variations as much as possible, but there's also something to chance effects. But chances are that a lot of the variation you see, there actually is a cause. So we go into our uh, fishbone diagram and we try to nail down that cause. Well, part of finding that cause and trying to track it down is by taking data and analyzing it. And for starters, we're going to look at histograms and Pareto charts. Histograms are of continuous data. That's the big thing here. So if it can be measured, and you can say that one thing is greater than another, or this one's longer, this one's shorter, this one's heavier, this one's lighter, uh, and you can put that in a continuous curve, then you want to use a histogram. And so you take you measure them up and you separate them out into chunks or buckets or bins, and you put them all of one particular measurement or a particular set of measurements, put them in one bin and count them up. And so you have frequency on one side and that continuum, so frequency on the y-axis and continuum on the x-axis. We'll get into that. And so it's not categories. So that's where Pareto charts come in. So we're looking at categories then. So are they colors? Are they items? Are they uh, you know, book types? I mentioned different types of books. Uh, so if it can't be measured, you can't necessarily say that a self-help book is greater than a nonfiction book or something like that. So you can't really measure them in that kind of a normal way, but they still can be counted. So you still have frequency on the y-axis, but then you've got categories on the x-axis, and then they are rearranged from largest frequency to smallest. Now, sometimes it's not just frequency, as we'll see, but frequency is quite common to use for a Pareto chart. And so then they go from large to small. Now, the whole purpose of all of this, all this plotting and so on, is to tell a story. Okay. And you might think, wow, this is really dry. This is statistics. This is analysis. Is trying to get a very clear, precise number down. But what it really does is it tells a story. So you can see in analysis of politics that as political groups, we have gone from maybe the left and the right or Republican Democrat, and they slowly grown apart, and so there's even more of a divide. Well, these are all numbers talking and people asking questions and just ranking them and putting them into an analysis, but they tell a story of how our country has become more polarized. And so you can see a story seeing how a disease has risen and fallen, or maybe uh, a car company has a whole bunch of problems and then reduce them. Whatever it is, these numbers will tell a story. So your job is to track down these numbers, possibly do the measurements, look at this analysis in an appropriate way, and then find out what the story is. All right. So that's the big overview. Let's go to how to make these kinds of things. So we are looking at right here, just a sample histogram Pareto set of data, and we took in class the data of how tall everybody is. All right. And we also have weight. We can deal with weight at another time. But this is good enough. This is a nice set of data. Now notice that we have 11 data points, pretty small data set, but that's okay. That's what we got. And the nice thing is that it runs from 63 inches to 77 inches. Now, you might say that that's 14 sizes, but that's not correct. That's 15 sizes, because if you start counting with 63 as one and going on up, that's to 77, that's 15 sizes. So what it really is, if you think about it, it's 62.5 inches all the way to 77.4999 inches, which is effectively 15 inches. So, each one of these measurements, 63, 64, 65, is actually that number of inches plus or minus half an inch. Okay, so each one of these is a measurement. It's a size. Okay, so for our first category here, 63 to 67, you just go through the list here and you count how many are in there, and we had one, so that just that one. 68 to 72, how many are size 68, 69, 70, 71, 72? 5 different sizes. Well, there's 1, 2, 3, 4, 5, 6, and I missed one. I think that one, 7. Okay, so we got 7 there, and then 73 to 77. We have 74, 73, and 77. Okay, so we got 3 of those in that size. Okay, so here we have 3 bins, this bin of sizes, this bin of sizes, and this bin of sizes. If we had a lot of people in class, we'd probably have a larger range, number one, but we could maybe break it up into as many bins as there are sizes. So 63 inches could have its own bin. All right, but we don't have that many, and so it would look really flat and really kind of unusable if we did it with this smallest set. So we're going to use it this way. So this is one way of making the histogram in Google Sheets. So go to insert, or I can just go right over here to insert chart. And we don't want this one. We want to use a different chart. So I just have to scroll up there. And okay, so the way I have it set up is a smart way, which is going across, and then it gives you the labels down here. But notice it's not actually labeled fully, because it has no units. It has no, I don't know if this is pecans or if it's inches, and this doesn't say anything about it either. This could be frequency, or it could be, locksmiths. I don't know. So you have to go through and do all the labeling yourself. So you go into customize chart title X. Okay, so chart title, and frequency, if I can spell properly, of heights in class. Okay, so is that title font size? I'm not going to do that. Series. Okay, legend. All right. All right, let's see if I can find that one right. No. Okay, why is it not showing me axis titles? Oh, here he is. So I go here. Okay, horizontal axis title, height, inches, and then vertical axis title, frequency in persons. All right, so this is a lot better setup, and I'm sure that you can go through the different settings yourself. Okay, so that's my first stab at it. But I also realized, this chart doesn't give me a lot of information. It's only got 3 bins, and it doesn't really show me the distribution that well, because the buckets are so large. They're a third each of the entire range. So, I think I'll make it the 5 buckets instead. So here are my 5 buckets, and I went through and I counted. And so I'm going to do that again. And now automatically grab the one that I had before, which is great. And let's see, make it a little bit smaller. All right, now this tells a little bit more of a story here. It clearly shows that we are skewed to the right, that we have a lot more people in the 72 to 74 range than we do down in the lower areas. So this is skewed to the right. We'll talk more about skewing in a week or two. But so, these are very tall people up this way, and there's only one of them. But what this really tells you is that we are, part of the story here is that we have more males, many more males than we do females in the class. So there are 2 females in the class, 1 male. I believe this is one of the females. I believe this is one of the males, and then another female I believe is here. So this is why it's skewed to the right, and that's part of the story. All right. Okay. Next. So this is a simple example, but notice how I went through and I just counted each one. But if you've got a lot of data, or you have to do this over and over again, it can get very tedious, and then you start getting into errors, and you don't want errors. So let's go to the M&M diameters here. So I've got one bag right here. So bag A is there, and then all M&Ms here. And this is from some data from last year. So one of the things you want to do first with any of this kind of data is you want to get an idea of the range, and maybe I pick out a bin size. The number of bins is highly dependent on how much data you have. Heard that the minimum number of bins you should have to make it really worth your while is 7. But when you've got small groups like this, maybe like the last one, maybe 5 is more appropriate. But if you have, thousands of points of data, you can have a lot of bins, and you still have you can show a really nice curve. But first things first. So we're going to type equals min here, because I don't want to sit here and look at it and try to figure out which one's the smallest. Okay. No, it's not going to do it that way. All right, so then I'm going to lose my, there it is. All right, so I'm going to go minimum and maximum. So I'm going to do equals max and drag through. Make it look all nice. Okay, so the maximum here, and then we also want to find the range. The reason why we want to find that range is because this should be able to tell you maybe what's meaningful in terms of the bin size that you have. If your range is just 0.002 and you're measuring them in 1/1000th of an inch, it almost makes you wonder, why are we even doing this? Because you only have effectively 2 or 3 measurements that are actually showing up. But here I've got 14 bits of data, and they're spread out over, and they're measured to the thousandth of an inch, and they're spread out over 49 thousandths. So that means that it's pretty spread out. So this should be interesting to watch. Now, Google Docs is really lovely and makes things really easy here, the Sheets thing. So I just select just the data, and I click right here, and it says line chart. We don't want a line chart. No. We want to go down here to the histogram chart. So it will effectively do this for you. The problem is that it's going to do an automatic on the bucket size. So bucket size automatic. Now I learned that what you want to do here is not don't take these, because we're doing things in thousandths of an inch. So if I want them in 7 thousandths of an inch series, I have to point in 0.007. So it's not the number of buckets, it's the size of the buckets. The problem I'm finding here is that then it doesn't reflect the thousandths of an inch down here. So I've got to it doesn't give you that opportunity to put in the precision down below. So that's kind of annoying. It's actually very annoying, but maybe someone can figure out how to do that. So here we have another story here. It's an interesting story in some ways, or at least we don't know the ending of the story. It looks like we've got a fairly flat distribution here, and suddenly right here, like there's a whole lot of M&Ms, and then there's a few more, and then drops back down to this level. So it just makes you wonder what's going on to make it suddenly go like this, and then there's this. Like, what's up with that? Okay, like there's nothing, and then there's 2 here. But also, you should say, you know what? This is only 14 data points. There's really not much we can say about this. So we're just going to take that. Of course, you guys should label these and so on. Oh, that's right. That's how I have that done. All right. So let's go over here and see what this one does. All right, so let's gonna do equals min here, and ooh, much lower this time, equals max of the same data. And equals this minus that. That's our range. All right, so we have, notice, let's compare the range and the min and the max to the one. Notice how if you have a larger data set, if you have a larger data set, you're going to have a much wider range, usually a much wider range. This is almost 4 times the range because you're just going to find that many more outliers. Our minimum is much lower than the smaller sample size, and our maximum is much higher than the smaller sample size. So you're going to get a lot more dispersion and range than if you just look at the one. So this is, again, why I keep always saying the more data you can get, the better. All right, so now I'm going to select this, go here, and yeah, then it actually creates it in whatever window you're in. So I wanted to bring it up top. But let's go to customize and histogram and make it that bucket size the same, 0.007. All right, now this is a different looking story than what we had before, isn't it? Okay. If I copy the chart, delete the chart, then bring it back up here. Let's go to 75%. Okay, so now we can see that everything's kind of, it's similar right here where we've got, some low-lying stuff, and then suddenly at this juncture about 0.50 it jumps up and stays up and then drops. Although here it jumped up and then dropped. So it just makes you wonder. And here, of course, we have these outliers that are way outside. Now, if we just look at this stuff and ignored the left and the right, we could see more of a curve. But it just goes to show you that the more data, the better. You're not going to get this story here out of this story. This tells a somewhat different story, not completely different. You've got the big jump here, okay? That's what you get here. But you're not seeing the outliers in this one, and you're not seeing the consistent rise from 0.50 to 0.53 that you're getting in this chart. So it makes a big difference. Okay, so these are histograms, and they work on a continuum basis. So if the one on the right is greater than the one on the left, and it continues going up that way. These are not categories. They are put into, but they are put into bins. In this case, it was a bin of 0.007. Over here, it was a bin of 3 inches. So for this one, and 5 inches for this one. All right. So now we're going to go on to Pareto charts. Now they're going to tell a different kind of story. And here we have categories of different colors. Now, oh, yeah, I originally had these cut from, okay, I'm just going to maybe go back here and all right, so all right, so we got them in alphabetical order, but that means the numbers are all mixed up here. So in order to do a Pareto chart, these things have to be in order of largest to smallest. Now, is it possible to create a spreadsheet programmed so that it goes into this and does largest to smallest? Yes, it is possible. I'm not going to show that here. So what you might want to do is what I'm going to do here, which is I'm going to copy this. So you can do this if you like the way you had it on your spreadsheet. I'm going to do this, and then I'm going to right click here, and I'm going to paste special and just paste the values. Because otherwise, if you have formulas, it can get kind of wacky. The problem with pasting values is that you've cut off any way that this is going to connect back to something else. Maybe if it's changed, if you add data, then you're going to have to redo everything from this step forward. So I'm going to take the data. I'm going to sort it. I'm going to sort it by column B because that's where the values are. And I want to do it from largest to smallest. All right, so I've got those. I'm going to select them again, go to a chart, and it set it up as a column chart, which works just fine the way I have it set up. But of course, you'll have to make the labels and so on. So this is our column chart, and we're going from largest to smallest. We have categories. They can't be told like orange is greater than blue or red is greater than orange. If you really want to go with like Pantone colors, or if you want to go with frequencies, then yes, I guess you could make things larger to smaller. But in this case, is it really meaningful or even worth it to do? No, it's not, because you're not going to get any other shades outside of these in a bag of M&Ms. What's more is that I think some of these mixtures of colors, such as brown, don't have specific frequencies. So they're we'll see how that. Yeah, I'll let you figure that out for now. But so it made it fairly easy to do that. So the thing is, here is the data from all 8 of that person's bags of M&Ms. And so you can see here that with one bag, we had a lot of green, a bunch of blue, a bunch of orange, a little red, and no brown or yellow. So you could say, oh man, there's no brown or yellow. Maybe those were your favorites. Maybe they weren't. Maybe you hate green. I don't know. But then, you could say, boy, that M&M company, they're just not doing their business. They're just not doing their thing. Because you might expect in a group of 14 that you would have 2 of each, maybe 3, but that's about it. Maybe if you had 15 or 16, you would have 2 or 3 of each. That would be evenly distributed. But random is not the same as evenly distributed. Now, over the long haul, they'll probably be a lot closer to being evenly distributed. But even when you had all 8 bags times like 14 or 15 of them, and so I guess that's, how many did we have here? A total of 110. We still didn't have it perfectly evenly distributed. All right, now I'm going to take this and I'm going to rearrange it. I'm going to sort by column G, largest to smallest, and nicely the chart itself also changes up. Now this is more evenly distributed, but what's really interesting is that where we thought we were going to have a lot of green, no, green is actually the second lowest. A good chunk of the green M&Ms in our entire population came from this one bag. So 5 out of the, 13 came from just this one bag. But reds are low, yep, for this population. But surprisingly, we had a good chunk of yellow and brown, but over here we would have predicted that we had 0 yellow or brown. So more data, better. And I can't tell you how many people, just use like a single point of data and assume that, yep, that's got to be what the whole population is like. And they're often quite wrong. And then they make bad decisions. Okay. So let's look at maybe a little bit more complex aspect of Pareto charts, is that seatbelt example that I gave before. So we have a seatbelt company that tested 1,000 or looked through, inspected 1,000 of their seatbelts, and or maybe it was 10,000. Just frequency per 1,000 is this, and we've got this, and we can change the sorting this way, and then create a Pareto chart. And based on this Pareto chart, you might say that we should address, if say we have limited resources, we should address the seatbelts that are too long, and then the ones that are frayed first, because if we get rid of those, then we'll have a lot fewer problems per 1,000. Just those 2 problems alone are going to address a lot of our issues. But that isn't the whole story. Again, this is about stories. So someone in class brought up the fact that, well, what about safety? All right, well, our engineers went through what's called an FMEA, which is a failure modes and effects analysis, and they ended up with an RPN, a risk product number, and for a one being too long, they thought that there was very little risk involved with that. There might be some minor issues going on, so it came up with an RPN of 4. If it's frayed, they found that maybe it's not that critical, but had an RPN of 6. Too short, some people might not put it on, and so they came up with an RPN of 20, which is actually fairly high. I think 25 is often what I've dealt with as the highest. And too narrow, that's similar to the frayed, so that's 6. Off color has no safety issues whatsoever, so that's a 0, and won't engage. Well, if it won't engage, it's not going to work at all. So we've got 25 there. So then we multiply them out, weighted safety. So if we had no devices that wouldn't engage, it wouldn't make any sense for us to address that. So, but if we had a lot, then we would want to. So we want to quantify this so that if based on safety, which project should we address first? So take this times that, and then we drag it down. And so based on safety, okay, let's see, take this and we do data sort, and we want to sort by E, largest to smallest. Okay. So, oh, you know what? I'm going to undo that. I'm going to take this. I'm going to download it as a PNG so we can keep it. Copy, paste. All right, so we're going to keep our original there. Take this one, put it over here. All right, so then we'll do that sorting thing again. Sort by column E, largest to smallest. Okay. So then we're going to take this and we're going to edit it. Going to, we've tried it a few different ways, and the best way it seems is a little bit clunky, but we're going to add the series. So add the series, click here, drag down here for this range, hit OK. And then see now that you got two series on here, which can be helpful sometimes if that's what you want. But instead, we're going to delete this series. And now we've got our Pareto chart from largest to smallest. So this indicates that we should address the too short issue first, the too long issue second, frayed, and then won't engage. Okay. Okay, let's go to, oops, download. All right. All right, now there's another way of looking at this too, and that has to do with cost. Cost per defect. So if it's too short, well, it's gonna cost us a whole new belt, and the time to put it in, it's gonna cost us $5. If it's too long, we just can cut it and sew it back on the edge, no problem. It costs us $2. Frayed, we can get rid of those pretty easily, sell them at a little discount. There, won't engage, we have to throw the whole thing out. So it could cost us, 25 every time that happens. And if it's too narrow, we can do the same thing as with frayed. Off color, we can do the same thing. We can just sell those. So there's not much of a horrible cost differential. That's only if there's a few of them that we're trying to get rid of. If we had all of them like that, then we'd be in big trouble. But we can usually offload a few of these to like bumper car racing or something like that. All right, so now I'm going to multiply that out. Total cost equals that times that. Drag it down. And then we're going to do that one more time, is that we're going to sort the range from G and do it this way. So there we go. So of course our chart didn't catch up. So we got to change that again. Edit chart, add series. Don't forget to click here. I don't know why it's so annoying to do, but there we go. Hit OK. Get rid of this series. Get out of here. Okay. Of course, should be properly labeled and so on. But now we've got our three different things. And in this case, won't engage, that actually costs us more money. Too long, that costs us more money. Too short. Now also notice that these three are the vast majority of the cost, whereas these three are pretty easy. They don't cost us that much if there's a defect. So if we're doing it on basis of cost, you want to start with won't engage. If you want to do it on the basis of RPN safety, you do it on too short. If you want to do it on the basis of too long, or on the basis of frequency, then you address too long first. So there's a variety of ways of looking at it. Now, there was another question about how to make some of these using, doing the counting thing. And I think that was back on the M&M diameters. So I'm going to address that now. In order to go through and use the count and make your own bins, let's just start with something simple. Okay. So if I wanted to just count over here, how many are of 0.510? I open this up, equals COUNTIF, and I just select this data, put a comma there, and then I can type 0.510. Hit enter, and it counts 1. Now since it's counting, it's going to be 1, 2. It's going to be some integer number. So I'm just going to get rid of decimal places. Okay, so if I instead make it 0.519, guess what? There's 2 of them there. So this one here and where'd it go? There's another one right down there. All right, if I make it 0.500 exact, there are none in that. Even though there's, they cover that more or less that range, there are none here. Okay, so say I wanted to change the that number a little bit more easily. So I'm going to enter 0.5 here, and I want this to refer to that that cell. First off, I have to tell it how I want it to relate. I want it to be equal to, and I have to put that equal in quotes. Not exactly sure why, but I've got to do it. Now, if I want it to refer to a cell, I have to put the ampersand in there and then click on the cell. And I couldn't click on the cell because it's like right there or something like that. There it is. I really want B21 here. Okay. So might have to enter it in like that. All right. And so now it's looking at that. So if I type in 0.519, that number comes up as 2, just as we said before. All right. So now I can also tell it how to relate in this way. Greater, I can do equals. Instead of equals, I can do less than B21. So there are 6 in that range that are less than 0.519. There's 1 that's less than 0.500. And 8 that are less than 0.52. So it can, doing this you can change things around fairly easily. All right, if I wanted to instead make, let's see. All right, so only 6, but two of those values are 0.519. Let's see if it'll let me do this. Less than or equal to. Aha! So there are 8 that are less than or equal to 0.519. All right, so that's great. Now, I'm going to set up over here my bin sizes. All right, so I've got 0.408. Actually, I'm going to do an equals this thing. All right, and I want my bin size to be 0.010, just to make it nice and easy. 0.01. All right, so I'm going to make this equal to 0.408 plus 0.1, but that's actually then my next bin size. So I'm going to cut that. And what I want to do is make this one equal to that one minus 0.001. All right, so I've got 0.408 to 0.507. And I'm going to keep making this Times New Roman, even though it doesn't like it when I do that. There we go. All right, and we're going to go all the way to probably 0.590 something or other. Okay, I did this wrong. Plus 0.1 should have been plus 0.01. That's better. All right. All right, so 0.598 is what it goes up to. And that should take in my entire range, so that's good. And then this should work just fine up until about that point. So if I do this one more time, this is going to be fine. All right, so now if I want to find out how many of the ones in that range are in between those ranges, so I can count how many are in this set of data and that set of data, and I want them to be less than this, oops, less than, okay, and this one is L18 and L18. I should get 0, okay, because everything should be less than 408. All right, now I'm going to take how many, I'm going to do this exact same thing, copy. Oh, you know what? I need to have dollar signs in front of this because I'm going to keep that whole range the same. Okay, and I'm going to copy all that. And I want to take how many are in the next one, L19. Okay, so what I did is I found out how many were less than this one, L19, in this range, and I subtracted how many were less than this one. So it should be one was less, or was in that range. So I'm going to keep this, and I'm going to drag it down here. And you're going to find out a very similar situation as what we had up here. There's one here, then none for a while, then 2, then 4, and then 26, 35, 39, and then it drops. Boom, 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 boom. And then it drops in these various levels. All right, I'm going to change this around here. Goes G7. I'm going to change this to 0.400. Okay, now everything is down to more manageable numbers. And let's see. Yep, and it all works out here. So you can see that my my numbers are good. So I'm going to take this. I'm going to make my insert chart. I do not want a line chart. See, it's not going to be a histogram either. Column chart. Row 18. Now use column K as labels. Now, okay, so this is, I think, where we want to. It's interesting how it asked me if I wanted column K as labels. I'm going to take this, cut, and I'll cut it here. Cut, paste. All right, so let's see if this will help. Aha, that's exactly what happened. Now it came up with a very similar graph, and I've got nice numbers down here that are exactly, 0.4, 0.41, so 00, 410, 420, and so on. And it gives us a pretty good story of what's going on here. Is that very, very almost certainly that they're shooting at the M&M Mars company for the diameters to be in the 0.5 to 0.52 range. Everything is dropped off. These are outliers. Strangely enough, we've got some fairly large ones out this way and a couple, a few small ones this way. But there's definitely some uh, shooting for this. Now, this one is an interesting, different graph. It's got, again, in 007 buckets rather than 010. So it gives a little bit finer grain detail of what's going on, whereas this is a little bit coarser. So, and shifts where the difference is between the buckets. All right. Well, I hope that that helped out. Let me just show this formula again to you guys a little bit more. This COUNTIF. So I'm counting if that range of things is less than this, and then I'm subtracting the ones that are below that. So I've got this many here, this many here. What's the difference? So I'm just finding that little block that is in between each of those levels. Is there an easier and faster way of doing this? Almost certainly. And, obviously you can just click on that data. But I think this is a great thing to understand how to do, because somewhere along the line, you're going to want to know something very specific. You're going to want to be able to program it. Chances are you will be able to program it if you put your mind to it. All right. I hope this was helpful in what you're looking for. And I will, if you need anything else, let me know. Thanks.